So by now, we have covered quite a variety of different proof techniques. However, these are by no means exhaustive. There are many other different sorts of proof techniques that are out there that you can occasionally run into. So the plan for this whole section is to cover some of these other different proof strategies. And these are going to be briefer proof strategies that we're going to explore in a little bit less detail than the other ones. Sort of an assortment of extra tools in your proof-proving toolbox, as it were. This content is covered in this section of Rosen, as well as in these sections of the Book of Proof. So the very first other proof strategy that we're going to talk about is existence. So sometimes you're asked to show a statement like the following. You want to show that there exists some x such that some statement p of x is true. So if you were asked to show that that statement is true, there are basically two different ways that you could go about doing this. The very first way is you could actually go and find some explicit x that satisfies p of x and makes that statement true. That's called a constructive existence proof. So a constructive existence argument actually goes out and finds some explicit x such that your statement p of x is true. On the other hand, there's a technique for showing existence proofs that's called non-constructive. So a non-constructive existence proof is basically some sort of argument about why such an x has to exist, but you don't actually construct or demonstrate or give such an x value that makes your statement p of x true. And so these are two different ways that you can do an existence proof. And let's go ahead and look at an example of both of these. So for the very first one, let's look at a constructive example. So here in this example, we want to show that there exists some solution to this equation, x squared plus y squared equals 13, where x and y are natural numbers. So you can see that this is a statement of there exists an x such that p of x. So the statement in this case has two variables, so it'd be more like x and y. So find an x and y such that x squared plus y squared equals 13. So typically for constructive existence proofs, what you do is you either guess and check, or you perform some sort of search, or maybe you do some complicated machinery to go about constructing some solution or some x that satisfies p of x. So in this case, it's actually not too difficult to be able to do this proof because I can just go ahead and explicitly, constructively find you an x and y that satisfies this equation. So here I'm saying, well, let's let x equals 2 and y equals 3. Then all I have to do is plug in and check whether or not this equation is satisfied. So x is 2, so 2 squared, that's going to be 4, 3 squared, that's going to be 9, and oh hey, 4 plus 9, that indeed is 13. And I am finished with my proof. So a constructive proof, pretty simple. I've just constructed you an example. There we go. I have found a solution here that satisfies this equation. Non-constructive proofs, on the other hand, can be a little bit more nuanced because instead of constructing explicit x's and y's, we have to actually make some sort of argument. So that's what we're going to look at next.